All right, what do you call a twitching cow? Beef jerky. I thought that was a pretty good one. Okay, so to we've covered areas. Now for this particular lesson, we're going to look at area of composite figures. Composite just means we're made up of parts, okay? More than one part. And the idea here is you want to calculate your parts separately, and then you use addition and subtraction to find the total area. Okay, so I've got a couple questions. The first one here, find the shaded area to one decimal place. We've got this weird little shape here. Now, there's more than one way we can break this up. Say, for example, I could break it up here and deal with two rectangles. I could also break it up this way. Those would probably be your most ideal. Now, given the measurements, I think it would be easier if I do this. So I can see here there's area 1 and there's area 2. So if I talk about area 1, I can see that the height is 10. And also I'm going to have to do a little bit of math here. This whole section here is 12. This little section here is 8. So that means this section in here must be 12 minus 8, which is 4. 4 centimeters, if that makes, or 4 meters in that case. So area 1 is a rectangle, base times height. 4 times 10 equals to 40 meters squared. And let's now talk about area 2. Area 2 is a little bit more straightforward. You can see it's 8 by 6. So I just go 8 by 6, which is 48 meters squared. And now I know that my total area, I just add them together because they're two big areas. So 40 plus 48, which equals to 88 meters cubed. That there becomes your answer. Okay. Now, of course, that's a simple concept. You may get a question that looks a little bit more like this. Let's find the area. Now, in this case, I didn't need any decimal places, so I'm just going to leave it as 88. Just to be safe, this is probably a little note I should talk about. If they say to one decimal place and it's still a whole number, give them the one decimal place, just in case. Okay. And again, this is in meters squared because we're talking about area. Now for this one here, we've got this great looking donut thing. Now I can see that I've got essentially two circles here. Okay, so I'm going to talk about these two circles as maybe area 1 and area 2. And so let's talk about area 1. We know that a circle is pi r squared. So for area 1, pi times, and the radius for the first little circle is definitely 2 centimeters. So I'm just going to go pi times 2 squared. And let's see what that gives us. Pi times 2 squared gives us, and I know I want to answer to one decimal place. So for now, I'm going to answer it to two decimal places. So it should be 12.566, which rounds to 12.57 centimeters squared. Let's find area 2 now. Now, area 2, I can see with the bigger circle, technically my radius is not the whole 9 centimeters, it's actually 4.5. Okay, so for this one here, I've got pi times, it should be pi times 4.5 squared. And this gives you 63 point, it says 617, so the two decimal places is 63.62 centimeters squared. The reason that I kind of give a little bit extra is so now when I do the total, now for this one, because I'm almost taking out, it's like I've started with area 2, the big green area, and then I'm taking away the little area in between. So it's clearly a minus question. So I'll go 63.62, take away 12.57. And let's see what we get here. 63.62. Take away 12.57. I should get something like 51.05, and this will be centimeters squared. Okay. So, yep, some questions will be plus, some questions will be minus, depending on if you're taking away an area or you're adding two areas together. Hopefully that makes sense. Okay, now there's one more. There's one where we can use Pythagoras' theorem. Just remember a squared plus b squared equals to c squared, where c squared is C talks about your hypotenuse. Hypotenuse, or your longest side. Okay, in case you've forgotten, the longest side is always opposite of your right angle. Okay, the opposite side. Now, what I've written here is a squared plus b squared equals to c squared. That's how you find the hypotenuse. Or you could go a squared equals to c squared minus b squared, and we're going to use that one if we're finding the shorter side. Okay. Now, for example, they might give you a question like this: find the area of ABCD, so the giant quadrilateral that's a little bit of a weird shape. Now, the way I can see it is it's definitely just two different triangles, and so I'm going to almost draw them down here. There's A, B, C. That's A, that's B, that's C. I know the base here is 4 meters, and I know I should probably draw it a little bit more accurate. Hey. So I'm going to break it down into the two different triangles. So pretending this is ABC, the length from A to E, they say is 10. They say from E to C is 4. So I can see here that that's a length of 14. I can see that that's a height of 4. And so how do I find the area of this triangle? Half times base times height. Okay, so that would be 28 meters squared. Okay, now the harder question is I'm going to have to break this part into two different things. The first part is I definitely need to find, oh, here, let me show you what I mean. I've got ACD. Will that fix? Yeah, okay. Now, I don't know this height. I know that's 4. I know that's 10. I know that's 12, but I don't know the height. Okay, I have no idea what the height is, but I recognize that, okay, that's a right angle. And so if I take this one step further, I'm trying to find a shorter side here. I've got 10, I've got 12, and I've got an unknown. I'm definitely going to need to use the Pythagoras theorem. I'm definitely finding a shorter side because it's not the hypotenuse. So in other words, it's kind of like x squared, because that's my unknown, equals to 12 squared minus 10 squared. And I know that this, put in your calculator, this would be 144 take away 100, which means x squared equals to 44. But I don't want x squared, I just want x. So I take the square root of 44. And I can see that x would be approximately 6.6 to 1 decimal place. And so I can see here that my height of this would be 6.6. Okay, hopefully you can see that. So how do I find the total area of this blue triangle here? And I'll do it in blue. Area equals to half times base, which is 14, because that's the whole from here to here. The 10 and the 4 make 14 as your base, times 6.6 as your height. And let's see what that is. It should be approximately 46.2 meters squared. And so what's the total area? That means ABCD. The total area is 46.2 plus 28. I'm sure you can figure that out, which would be 74.2 meters squared. All right, hopefully that helps. Just don't forget Pythagoras theorem is a little bit of work from year 8, 9, 10. So hopefully that's a bit of a refresher for you. All right, hope that makes sense. I'll catch you guys in the next one. See you later. Bye.